Hello. So we are looking at an exponential function where we are supposed to we want to sketch it. So here we want to sketch the exponential function. And when you sketch the exponential function, what you need to check is actually your a, because here in this case here we are just write the standard function is y equal to a. What is it? A b to the power x. Okay, so b to the power x plus q. So in this case here, we are looking at q as a vertical shift. So this one is a vertical shift and vertical shift. So in this case here, we don't have the q. So the q is not there. If the q is not there, we're just going to look at these two. Now, on these two again, when we see a negative, when a is a negative, that's a reflection in the x-axis. Then when a is positive, we know how it will look like. So let me show you here. Just a quick sketch, a small sketch for general function that we're dealing with here. If a is less than 0, we're seeing it, we take it like it's gonna be what is it? It's gonna be like that, going down. Then if a is above 0, it's actually gonna go up. Where is it cutting? That the next question is cutting on the 1. Okay, because we know that. So here is 1, and also here it's gonna be -1. So what we know is that when we put x equal to 0, any number to the power 0 give us 1. So now, because of the negative here, is going to affect what way it's negative. That's why we are putting it on the negative side. So we know that everything's going to be negative. So that's why we are writing it like that. So that's just remember to know the shape of the graph. What is it given? The A. Okay. So here is a quick sketch just for you to understand. Now let's sketch what we have here. When you're sketching what we have here, we just gonna say, okay, it's cutting on the x-axis. It's cutting on the y-axis. So in this case here, it's not a big problem because so here we're just gonna have -1. Now it's -1, and we know that it's a reflection along the x-axis. So we're gonna put it like that. Okay, so that's our graph. So it will never touch the y-axis. You never touch the x-axis, sorry. You never touch the x-axis in this case because there is no shift. So it's just approaching the x-axis. Okay, so in this case here, we are looking at asymptote. Asymptote here, it's y equal to -1. Okay, y is equal to y, not y equal to -1. It's y equal to 0. So y equal to 0 is our x-axis. Okay, that's the only asymptote that we have there. So that's an asymptote. Now, what about increasing and decreasing? Let's look at that. Increasing and decreasing. Now, increasing and decreasing here, we see that our graph can either increase or decrease. Now, in this case here, it's increasing, it's decreasing. Now, when it's decreasing, it's going to decrease, x element of real numbers. Okay, so but it's not increasing because the gradient here is negative. Okay, so x element of real numbers. Then when we talk of the maximum, does not have a maximum, does not have a minimum. Asymptote, we have picked it, and the shape, we can see the shape is a reflection on the x-axis because of the negative. Okay, so I think everything is here. And just a quick check here on the previous class where we have a quadratic function, a parabolic function, but on the decreasing here is gonna be, we're going to look at x less than 0. Or we just say x element of real numbers, x element of real numbers, but x cannot be equal to 0. Okay, so that's where it's decreasing. Then here, when we talk of the domain, sorry to take you back, domain here is x element of real numbers, but x cannot be equal to 0. Okay, so here we're saying not equal to 0. Then range is y element of real numbers, but y cannot be equal to 2. That's what it was of asymptote. So here we're just restricting the asymptotes. Now let's see here with our domain. Domain here is x element of real numbers. So it can approach any value of x. What about the range? Range is y less than 0, because we're just going to find our graph below 0. That's what we see. So it's not going to cross up there. So that's all what you guys need to understand. Thank you so much. Until next time.